Centers for Climate and Environment program. And my name is Petra Bogenschneider. I'm head of the unit at the DAAD headquarters in Germany, which is organizing this lecture series. And on behalf of DAAD, I would like to welcome you here today. And I'm really delighted that all of us have gathered here today to listen to you, dear Professor Germán Poveda. It's great to have you here today. And the DAAD is funding a total of 4 Centers for Climate and Environment with support from the German Federal Foreign Office. And all of the centers deserve the title of Global Centers. And so far, as they are based in minimum of 2 countries of the Global South and in Germany. And if you would like to find out more on the program, you also find the link to the program's website in the chat of the WebEx seminar. My colleagues just posted it there. And before I give the floor to today's chair of the session, Professor Erasmo Rodriguez from the Global Center of Climate and Environment Projects, who will also introduce our guest speaker today, I would like to provide you with a few organizational notes and also conduct a short survey with you, the participants, to get a little bit of an impression who joined us in the audience here today. So, we start with the technical details. Your microphones and cameras are switched off during the whole time of the lecture today, but you can ask questions to our speaker at any time via the chat, and we will collect the questions and post them after the presentation to Professor Germán Poveda after the lecture is finished during the Q&A part of the event today. As you may have seen, we are recording the event today, and we will also publish it on the DAAD channel on YouTube and also on our website. And yeah, to get to know a bit more who is here today with us, we would like to start our survey, and my colleagues will show the questions to you. And the first question that we would like you to answer, and you can of course choose only one answer, is from which world region you are joining today. So possible answers should be able to be seen on the side of the WebEx window, and possible answers are Sub-Saharan Africa, North Africa and the Middle East, Asia, Latin America, Europe, North America, or Australia and Oceania. And of course, you can also choose not to answer these questions if you would not like to do so. So please vote, and then we will have a look a bit from where you are joining today. And so far, it seems we have quite a good mix of different regions. Still, people are answering quite a fair share from the different world regions, with Latin America at the top. Then we have Sub-Saharan Africa and North Africa and the Middle East. And from Asia, we also do have a lot of participants, and the vast majority from Europe as well. So thank you very much for answering that question. And we have another question for you. And we would also like to know, probably also for our future events, how you got here today. What is the main motivation you joined the event today? Are you part of one of the 4 climate centers? It does not matter whether you're a student or a senior scientist or another member of the center, whether you are researching, studying in the field of climate and environment, but are not part of one of the climate centers, whether you have a particular interest in the work of Professor Poveda's work and his presentation today, or whether you are interested in the topic of climate and climate change in general, or in DAAD events in general. You can choose multiple answers here, and then we will have a look at it also. So please answer. We'll find the question in the same place as the other before. You've received already quite a lot of answers, and most of you are researching or studying in the field in climate and environment, but are not part of the climate centers. And there are also a lot of participants generally interested in the topic of climate and climate change in general. And yeah, we also have quite a few participants from all the climate centers around. So it's good to know that we really have a good mix of participants here today. And yeah, now it's time for me to hand over to Professor Erasmo Rodriguez, who will moderate this lecture today and also present as the speaker of today. So Erasmo, the floor is yours. Thank you very much.
Thank you, Petra, for introducing the talk today, and thank you, Professor Poveda, for accepting this invitation for this series of talks of DAAD. So, good morning to those joining us from the Americas. Good afternoon to our colleagues in Europe and Africa, and good evening to those in Asia. My name is Erasmo Rodriguez. I am Associate Professor at the Universidad Nacional de Colombia, and it's a pleasure to serve as moderator for today's talk. During the talk, please feel free to post your questions in the chat. It is a great honor for me to participate in this talk as moderator and to welcome Professor Germán Poveda, a distinguished Colombian hydrologist, climatologist, and water resources expert, whose work has profoundly advanced our understanding of the hydroclimate of the Andes Amazon region and the complex interactions between climate change, deforestation, and water systems. Professor Poveda earned his PhD in water resources from the Universidad Nacional de Colombia, following his undergraduate degree in civil engineering and a master's in water resources pursued in Colombia and the United States. He served for decades as full professor in the Department of Geosciences and Environment at the Universidad Nacional de Colombia in Medellin. Although recently retired, he continues to actively mentor students and collaborate on research, remaining a driving force in the country's scientific community. Throughout his distinguished career, Professor Poveda has made seminal contributions in several interconnected fields, including the hydroclimatology of tropical South America, the hydrological impacts of climate variability and change, particularly the El Niño Southern Oscillation, and the effects of deforestation and fires on rainfall patterns, runoff, and water resources in the Amazon basin. His work has been both highly influential and widely recognized. He has authored or co-authored over 200 papers in leading international journals, delivered more than 200 invited lectures worldwide, and his publications have accumulated over 12,000 citations. Among his many honors, Professor Poveda has received the Colombian National Prize for Scientific Merit, the Alejandro Ángel Escobar National Prize for the Best Scientific Work in Natural Sciences, and multiple awards from the Universidad Nacional de Colombia for excellence in research, teaching, and academic leadership. He has often been referred to as the scientist of the flying rivers and the climate, in recognition of his groundbreaking research on Amazonian moisture transport and regional hydroclimate dynamics. He has also been an invited professor and visiting scientist at world-renowned institutions such as the National Center for Atmospheric Research, NCAR, in Boulder, Colorado, the Hydrology and Ecology Center in Wallingford, England, and the Max Planck Institute in Germany, reflecting the international recognition of his scientific contributions. His leadership extends beyond academia. Professor Poveda serves on the Scientific Steering Committee of the Science Panel for the Amazon, and he has contributed his expertise to organizations such as the Global Energy Water Experiment, GWEX, the American Geophysical Union, AGU, the International Hydrology Program, and the Intergovernmental Panel on Climate Change, IPCC. Beyond his scientific achievements, his work carries profound societal relevance. By bridging climate variability, land use change, hydrology, and water security, Professor Poveda has illuminated pathways for strengthening ecosystem resilience and sustainable development in one of the world's most critical and vulnerable regions, the Amazon. In short, we are truly privileged today to hear from a scientist whose research unites foundational climatology, applied hydrology, and sustainability science, whose insights are central to understanding the impacts of climate change, deforestation, and fires on the hydroclimate and water resources of the Amazon. Please join me in welcoming Professor Germán Poveda. Thank you once again for accepting this invitation. Professor Poveda, the floor is yours.
Thank you, Professor Rodriguez, for your generous introduction. Good morning to all of you in Colombia and the Americas. Good morning in Germany, in Europe, in Africa, and good evening wherever else you are in Asia. So it is an honor and a pleasure for me to contribute to this climate lecture series with this talk about the impacts of climate change, deforestation, and fires on the hydroclimate and water resources of the Amazon River Basin. Next slide, please. We know that the Amazon is one of the 16 critical elements that keep in balance the Earth's climate system. These elements or these subsystems of the climatic systems are very well known, and they play a fundamental role in maintaining the stability and the balance of the climatic system. So if these subsystems are modified, altered, or disturbed, the whole climatic system of the planet Earth is going to change forever. The Amazon River Basin plays a fundamental role because of its size and its location. Next slide, please. Because the Amazon is located in equatorial South America, it provides a suite of ecosystem services not only to South America, but globally. It plays a fundamental role in reducing land surface temperatures, generating rainfall, storing around 200 billion tons of carbon in its soils and vegetation, evapotranspiring more than 20 billion tons of water every day, and exerting a strong influence on the atmosphere circulation patterns, not only in South America, but globally. Mainly due, as I said, to two factors: its size, more than 6 million square kilometers, and its location in equatorial South America. The river basin produces about 16% of all the photosynthesis in the biosphere and provide the largest river discharges on Earth, corresponding to between 16 and 22% of the world's total river input to the oceans. But the Amazon is not an empty ecosystem. More than 47 million people live in the Amazon, of which 2.2 million are indigenous peoples. Next slide, please. Let's start with the effects of climate change on Amazon that not only are happening today, but it will be worse in the future. As any other places in the world, climate change is increasing temperatures, rising temperatures leading to stress on plant and animal species. Climate change is altering rainfall patterns with changes in precipitation that impact ecosystems and agriculture, of course. And climate change is enhancing or exacerbating droughts and flooding associated with the increased frequency of extreme hydrometeorological events. Impacts are also felt on the extraordinary biodiversity, one of the most biodiversity-rich places on Earth, and it's causing the habitat destruction and fragmentation of forest that threatens countless species, some of which are endemic of the region. Climate change is disrupting the ecological relationship across many ecosystems in the Amazon, and is increasing the vulnerability to invasive species and diseases. Next slide, please. Of course, the economic and societal consequences of impact of climate change are that they are affecting the population living in the Amazon, especially indigenous communities that depend on the rainforest for their livelihoods. The economic sectors that are being impacted more heavily include water supply, agriculture, tourism, and forestry. And the challenges to climate change regulation due to reduced carbon sequestration and evapotranspiration reduction are being felt across the Amazon. Now I'm going to talk about the perhaps is for me is as important and threatening deforestation and fires is important and is compounded with climate change to enhance these problems in the Amazon. Let's start by saying or by remembering that deforestation is also one of the main causes of climate change and global warming, because it produces around 20% of greenhouse gases emissions in addition to burning of fossil fuels. So deforestation is also one of the causes of global warming. And this problem is compounding the effects of climate change in the Amazon. To see the extent of how this problem is developing or has been developing in South America, let's see this animation. Can you please start the video? Yes. Here we show, made with information from the Global Forest Watch, it shows in red points the dynamics of deforestation between 2001 and 2023. It is estimated that between 18 and 20% of the tropical rainforest has been already deforested, and nearly the same amount has been fragmented and degraded. So these red points illustrate how deforestation has been progressing in tropical South America, especially in the Amazon River Basin, with consequences that we are going to refer to a little bit later. Next one, please. Next slide. Yes. Can you put the photographs? Yes. So this problem spans across all Amazonian countries. For instance, this is not only related or associated to Brazil. These photos evidence the criticality of deforestation in the Colombian Amazon, and is even worse because in the Colombian Amazon, deforestation is going on even in the national natural parks, which are supposed to be preserved forever. But this is not what's happening nowadays. So the problem is more serious than we thought. And the consequences are being felt all across the Amazonian countries. Next slide, please. What I'm going to show you here is that deforestation threatens the stability of multiple ecosystem services of the Amazon basin. This video is going to show you how the water vapor is produced and transported in tropical South America. The video is called "The Beating of the Amazon Hydroclimate" because it illustrates the diurnal and nocturnal cycles of evapotranspiration. This video has been made with the results of a highly sophisticated climate model. It is a three-dimensional visualization of humidity, water vapor over the Amazon basin and South America from December 2004 through March 2005. Green and white areas represent higher levels of moisture going from the oceanic evaporation and from the rainforest evapotranspiration, and purple areas show lower humidities. Here we can see how water vapor is transported from the Atlantic Ocean inland, and it is re-evaporated by the trees of the Amazon rainforest. Of course, the Andes form a clear western boundary, and as time progresses, you can notice time in the top right, you can see the shifting extent and concentration of water vapor across the region. You can see how moisture accumulates over the rainforest and is then funneled to South and Eastern South America, illustrating how the Amazon water vapor is transported across the continent, reaching regions as far south as Buenos Aires and Sao Paulo in southeastern South America. So in this video, we can see the importance of the Amazon River Basin in regulating water supply, rainfall, and water for the whole continent of South America. Next slide, please. Can you run the video, please? Yes. Here we can see the fundamental to the function of the Amazon ecosystem is the role of the so-called aerial rivers or flying rivers, which are very large atmospheric wind flows carrying water vapor over long distances. They are fundamental to the global hydrological cycle, contributing to precipitation and regional climates. As we can see here, how moisture is transported all across South America from, as we said, the Atlantic Ocean over the river basins of the Amazon and the Orinoco, and then transported by the trade winds and several jet streams, in particular the Orinoco low-level jet and the South American low-level jet to the southeastern parts of South America. So these aerial rivers, these flying rivers, are very important to keep the water supply and the rainfall of the whole continent of tropical South America. So, and deforestation is threatening the stability of these flying rivers that are so important for the hydrology of tropical South America. This is a beautiful photo from of one of those flying rivers in action. These are not only metaphorical issues, but are very real issues that transport water associated with the existence of the rainforest in the Amazon River Basin. Next slide, please. Other impacts of deforestation on the Amazon hydrology, as we just saw in the video, there is a cascade of moisture downwind in the Amazon, which is at risk of collapsing owing to deforestation, due to the reduction of moisture inflow that reduces rainfall, in turn reducing evapotranspiration and reducing the outflow of moisture transported by the flying rivers and the winds over the Amazon and tropical South America. So this cascade could be destroyed if deforestation continues the way we have observed in the last 20 years. Next slide, please. Besides the water vapor evaporated from the Atlantic Ocean and carried inland by the aerial rivers, water vapor required for rainfall in the Amazon comes from the rainforest evapotranspiration. This factor, which is known as recycled rainfall, provides between 35 and 50% of precipitation in the Amazon, and thus the importance of halting deforestation and of recovering degraded forests to maintain this water vapor from evapotranspiration to feed local rainfall in the same in the very basin of the Amazon River basin. Deforestation is destroying this recycling of precipitation, of course, with the consequences that we have been discussing so far. Next slide, please. Deforestation also reduces the cooling of the atmosphere provided by evapotranspiration of the trees and the forests. In evapotranspiration is thermodynamically is a cooling process of the lower atmosphere. So an evapotranspiration occurs during the daylight hours. So during the daylight hours, a forest is like a free air conditioning provided by Mother Nature. If deforestation progresses, this cooling process is being reduced, also enhancing the problem of climate change and global warming. This is another ecosystem service that should be recognized and paid for, associated with the existence of the tropical rainforest beyond the sequestration of carbon. I mean, evapotranspiration should be considered as another ecosystem service that needs to be recognized and paid for in the discussion of the mitigation of climate change. Next one, please. Here, I recall that to mention that the Amazon and the Andes conform a coupled system of mutual feedbacks, because the Amazon supplies water vapor through the winds and the aerial rivers that trigger precipitation in the Andes. At the same time, this Andean precipitation return liquid water, runoff, sediments, and nutrients to the low-lying Amazon. And of course, this water supply is required for many purposes, such as agriculture, hydropower generation, and many other purposes. And of course, deforestation in each of those subsystems, the low-lying Amazon and the Andes, is threatening the stability of this coupled system that maintains the hydrological system in tropical South America in action. Next slide, please. Here we show an example of that importance of evapotranspiration and the circulation of the winds with water vapor to provide water in many places in the Andes. This slide shows what's known as the precipitation shed in Yurimaguas, a locality in the Peruvian Amazon Andes Piedmont, and it shows where does the water vapor for rainfall in Yurimaguas come from. As we can see, between 80% and 100% of rainfall falling down in Yurimaguas comes from the entire Amazon basin. You see the isolines 20%, 40%, 80, 60%, and 80%. So between 80 and 100% of precipitation falling down in Yurimaguas come from the entire Amazon River basin, and we can say the same thing, for instance, for the rainfall in Bogota in Colombia, or the rainfall that feeds the glaciers in La Paz and Quito, and they use these glaciers to provide water supplies to many capitals in South America. So deforestation in the low-lying Amazon is threatening the water supply for many, many cities in South America. Next slide, please. This slide, let me try to be pedagogical here. In this slide, we show how precipitation behaves depending on land cover over vast region of South America. We see on the left hand side of this slide, we see the distance from the ocean from 0 to 5,000 kilometers. And on the y-axis, we have how rainfall behaves with distance from the ocean. As you can see in the top figure, the red dots are regions over the Amazon region, and the blue dots are regions outside the Amazon River basin. In the top figure, you can see that over the Amazon River basin, rainfall increases exponentially from the ocean inland if we are on top of the tropical rainforest. But immediately we leave the rainforest, precipitation decreases exponentially with distance from the ocean. And the same thing for the two figures on the bottom part of this slide. If we go from the ocean inland over northeast Brazil, which is a very dry region, precipitation decreases, as we can see on the left hand side, with distance from the ocean, and immediately we enter the Amazon rainforest. Rainfall starts increasing exponentially with the distance from the ocean inland. So this slide shows very, very clearly how important is vegetation to produce rainfall, and how important is the rainforest to increase rainfall exponentially from the ocean inland. So the forest is fundamental to maintain the hydrological cycle in tropical South America. Next slide, please. Another impact of deforestation that it has been observed is the lengthening of the dry season, as we show here for southern Amazon region. As we saw in the video, this part of the Amazon is called the arc of deforestation, or the arc of fire. And here we can see in time, the red lines denote dates of starting and ending of the dry season. The green lines represent strong drought events in the Amazon, and the yellow line denotes the tendency to longer dry seasons after the 1970s. So one of the observed impacts of deforestation is this lengthening of the dry season. Next slide, please. This is another observed effect of the impacts of deforestation on the hydrological cycle of the Amazon South America. I won't go into the technical details of these figures, but I just want to mention that in this paper of Salazar and colleagues, we identified how the peak flows and the low flows behave with area in different sub-basins of the Amazon River basin. As you can see in the bottom right, of this slide, the Tapajós River is showing that the red line, for instance, for peak flows over the Amazon, and the blue line associated with low flows, those lines are separating. That indicates that in Tapajós, which is located in the arc of deforestation, for instance, the distance between peak flows and low flows is separating, meaning that the hydrological extremes are being enhanced due to deforestation. So those are some other problems associated with deforestation, which is the enhancement of the hydrometeorological extremes over the Amazon River basin. Next slide, please. And this slide refers to that several scientific studies have shown that ecosystems can exhibit phase transitions when critical thresholds are surpassed. In particular, for the Amazon, different studies, modeling and observational, show that if deforestation surpasses 20-25% of the rainforest, it may suddenly transition to a warmer, drier savanna-like ecosystem. That means that deforestation doesn't need to get to 100% to collapse the rainforest. This is much more critical since the current deforestation of the Amazon reaches around between 18 and 20%. So if we surpass the 25% threshold, the collapse of the tropical rainforest could be sudden and could be converted into a more drier or warmer ecosystem, putting in peril all those ecosystem services that we have discussed so far. Next slide, please. Here we can see also that fires associated with deforestation are also associated with air quality problems at continental scales. Can you please run the video? Yes. Here in the big fires of 2019, you can see here how carbon monoxide associated with the fires, deforestation and fires in the Amazon are affecting air quality at continental scales in South America. As you can see here in this slide on the left hand side photographs, you can see how Sao Paulo became at night at 2 p.m. associated with the pollution and the soot from the fires in the Amazon that brought the night into daylight hours as a result of this pollution, soot, and dust from the Amazon fires, affecting, as I said, water quality and producing important health effects in South America. Next slide, please. So I don't want to stop here because the panorama would be very pessimistic. So I would like to end with an optimistic point of view and how to get out of the crossroads that represent the permanent stress between economic growth and sustainable development. To face such a challenge in the Amazon, the so-called Science Panel for the Amazon was created in 2019 in a meeting held at the United Nations headquarters in New York, convened by the Sustainable Development Solution Network as a group of scientists concerned about the situation of the Amazon and how to propose and how to be included in the discussion to save the Amazon, so to speak. Next slide, please. So, next. Yes, so we created the so-called science funnel for the Amazon. You can see there the web link. So you can access all these documents for free. You can download it from free. And one of the main products that we have created so far is, next slide, please, is a book or 3 books associated with this assessment report of the Amazon issued in 2021, which is known nowadays as the Encyclopedia of the Amazon. It consists of 3 books, as I said, Focus, the first book in a thorough discussion about the Amazon as a regional entity of the Earth system with all those 13 chapters that you can see there. Next slide, please. Second volume is the socio-ecological transformation and the changes that the Amazon have been experiencing in the recent decades. Next slide, please. The third part is the solution space with a proposal for a new development model and sustainable pathways for the Amazon. You can see all the chapters associated with the book that you can download for free there. And also the Science Panel for the Amazon has produced a series of policy briefs, such as the one shown here on a call for global action to move the Amazon system away from tipping points. So, other policy briefs have dealt with the strategies for large-scale forest restoration in the Amazon, or conserving Amazon freshwater ecosystems, health and connectivity, and so on. So these policy briefs are very important from a perspective of solving these this tremendous problem for the Amazon. Next slide, please. And of course, the strategies and solutions to achieve an Amazon in the science panel for the Amazon include the conservation and sustainable management and the restoration and recovery of ecosystems, developing a socio-bioeconomy based on standing forests and running rivers, and strengthening the governance and Amazonian citizenship, including expanding participatory intercultural education, harmonizing policies across multiple scales, and coordinating cross-border activities. Next slide, please. For that reason, the SPA recommended 4 major urgent actions for the region. First, impose a moratorium on deforestation in areas approaching to a tipping point. Second, to reach zero deforestation and degradation by 2030. Next slide, please. Third, to restore and to remediate degraded and polluted terrestrial and aquatic ecosystems. And fourth, developing a vibrant bioeconomy of healthy standing forests and flowing rivers. Next one, please. And of course, to save the Amazon, the leadership of the Amazon countries is going to be very important, as is going to be discussed in the next month in the COP30 in Belém in Brazil. And also, if developed countries claim that the Amazon is part of humanity's heritage and that provide ecosystem services that benefit the world, they must finance its preservation with considerable resources, including financial, scientific, and technical resources. Next slide, please. Last but not least, among the recommendations of the scientific panel for the Amazon is the need to recognize and to include and involve the ancestral environmental knowledge in activities of environmental education and environmental discussion, as well as the decision-making and policy construction in the Amazon of these indigenous people. In fact, several indigenous people from the Amazon are co-authors of several chapters of the 2021 assessment report of the scientific panel for the Amazon. So with this, I think I stop here. Thank you very much.
Thank you, Professor Poveda, for such a nice presentation. It gave us more understanding of the importance of the Amazon basin for the regional and global climate, for sure. So we need to go from science to action, I should say. And we have several questions that I will pose to you. I think one by one. There are, I think, 6 of them. So I will go for each of the questions, and I will ask you to answer them. So the first is coming from Cepiso Muilla. He said, what measures have been put in place to reduce deforestation in the Amazon area?
Well, there have been different measures and, of course, different governments, especially in Brazil. With the policies of President Lula, first government, deforestation got reduced in the Amazon in an important way. But then came the government of Mr. Bolsonaro, who dismantled most of the measures and programs to stop and to curb deforestation in the Amazon. And then deforestation increased heavily, not only deforestation, but fires. I don't know if you know that Mr. Bolsonaro called himself Captain Chainsaw. And this is real because he wanted to reflect his policies and his government action with respect to the Amazon, exemplified by a chainsaw. So after the second government of President Lula, deforestation has been reduced already again. So in the Brazilian Amazon, these programs depends on these measures, and these strategies depend much on the government in turn. In the other Amazonian countries, deforestation is also a big problem because lack of governance, because of illegal economies, of different kinds of illegal economy, illegal mining, illegal uh, drugs, different types of illegal economies are involved in the Amazonian countries. So this problem is very serious, not only because of the uh, impacts of deforestation on the hydrological cycle and on the ecosystem services that we have discussed so far, but also because the forces and the armies, real armies, which are involved in the fight for territories in the Amazon, these forces are very strong, especially when they are associated with illicit economies. So the fight is very difficult. These forces are very powerful, and they are going to impede or to try um, to to keep their business going on, because the money associated with those activities is too much. So it's a very difficult struggle. It's a very difficult fight, not only because of the very weak governance in the Amazon, but also because of the power of these illegal economies that are in charge of deforestation and forest fragmentation in the whole Amazon.
Thank you, Professor Poveda. Following your answer, we asked you about the governance for the Amazon in a transboundary context, because each country is managing the forests and the water resources for its own point of view. So in your mind, what would be the best strategy to try to get together all the countries and to make action in that basin?
Yeah, that's a very important question, because Amazon is an entire ecosystem that covers 9 countries. So the action to and the measures and the programs to stop and to halt deforestation and to improve or to recover degraded forest has to be taken uh, in a organized and way for between the different Amazonian countries. And for me, there is an organization, OTCA, which is the Amazon Treaty Organization, countries, OTCA, Organización del Tratado de Cooperación Amazónica, Amazonic Cooperation Treaty pact between Amazonian countries. So I think OTCA is a very important institution to coordinate policies, to coordinate strategies, and to coordinate plans among the different Amazonian countries to act in a organized way in order to curb deforestation and in order to ensure the actions and the managements and the governance required to save the Amazon. Otherwise, the perils and the impacts of acting in a disordered way, in a non-coherent way between the Amazon countries, won't help to reduce the problem. And for that reason, I think the coordination between the Amazonian countries is very important to proceed in a coordinated fashion in order to reduce these threats and these perils of the impacts of deforestation on the ecosystem services and the hydrological cycle and the regulation of the climate in the world associated with the existence of the forest. So It requires coordination among Amazonian countries, but also it will require, as I said in my presentation, important funds, important resources, technical, financial, etc., from the rest of the world, because the rest of the world has recognized that the Amazon plays an important role in the regulation of the climatic stability, the hydrological integrity, and the maintenance of the uh, hydroclimatic stability of the world. So, given the importance of the Amazon basin, these countries, not only the Amazonian countries, but developed countries, will have to play a fundamental role in having these resources for the conservation and the restoration of the Amazon River basin.
Thank you, Professor Poveda. I will move into the next question. It was posed by Katia Thielborger, and she or he said, are key stakeholders, are politicians aware of the projected dramatic changes to the hydrological cycle? How do they respond? Can you make an impact on decision makers?
Well, part of the work of the scientific panel for the Amazon has been exactly that one. We need to move from the scientific assessments to the action and the policy construction, because we are not an intergovernmental panel of scientists. We are not. We started like 20 or 25 scientists in 2019 in New York, and now we are more than 200 scientists, not only from the South American countries, but also from US and Europe and other countries, concerned about the stability of and the integrity of the Amazon River basin. And now we are proposing new ideas and new programs to keep, as we say, a safe model of economic development, new development model for the Amazon based on flowing rivers and standing forest. And this model is based on the bioeconomy, because the bioeconomy is perhaps the most important advantage, competitive advantage that the Amazon countries have. The amount of new discoveries in terms of new patents, new molecules, new drugs, new medicines, new products derived from biomimetics or derived from bioengineering that are hidden in the Amazon rainforest is absolutely fantastic. But we need to preserve those ecosystems if we are going to discover all that richness which is hidden in the tropical rainforest. So, part of the work of the scientific panel for the Amazon is to be prescriptive or to suggest the actions and the plans and the measures that need to be taken in order to save and to restore the integrity of the Amazon River basin. And now we are going to participate in the COP30 with a strong representation of science from the scientific panel for the Amazon to insist and to keep insisting to the policymakers and the politicians and the presidents and the governments of the need to keep to restore the integrity of the Amazon River basins to avoid perhaps the likely occurrence of a tipping point that would destroy the rainforest to become a savanna-like ecosystem, putting in peril those ecosystem services that we have talked about today. So I think the work that we have done in the scientific panel for the Amazon has been very valuable, because we have been heard in different discussions. For instance, in August, there was a meeting of the Amazonian presidents in Bogota, and one of our colleagues, co-chairs of the scientific panel for the Amazon, Maria Los Peña, gave a speech in front of the Amazonian presidents, and the conclusions and the recommendations were very well taken by the governments. And now at the COP30, which is going to be held in Belém in Brazil, again, we are going to insist about the perils that deforestation of the Amazon imply for the South America and for the world. And of course, what are the ways and what are the solution space to restore the forest and to recover the forest, and also how to halt deforestation, and how to also provide a new development model for the Amazon populations. Because as I said in my presentation, there are almost 50 million people living in the Amazon, not only indigenous people, but there are large cities in the Amazon. There are different types of populations in the Amazon, so they have to be taken. They have to be considered, of course, in these decision-making processes and this governance that we are claiming. And my hope is that with these ideas that we have developed in the scientific panel for the Amazon are going to be taken seriously by the presidents and by the governments, not only of the Amazon countries, but also worldwide, because it's a program, it's a policy program based on scientific knowledge. So I think if we are based in the scientific knowledge, we can have we could have a lot of power, so to speak, to propose a new development model for the Amazon River Basin. So my hope, I am optimistic from that point of view, that these ideas are percolating into the governmental action of the Amazonian countries in order to save the Amazon from the perils that we have talked about today.
Thank you, Professor Poveda. I also agree with you that the COP30 in Belém will be a nice opportunity for showing all the work that the scientific panel for the Amazon has been done during the last years. And also, as the COP is developing there in the Amazon, it's such an opportunity to show politicians and stakeholders about the opportunities to make decisions on the ecosystem based on sciences, I would say. So thank you. I will move into another type of question that are more related to monitoring. So one question asks about how forest monitoring technology systems expanded through the entire Amazon, and how the extent of the collaboration of South American countries to maintain the biodiversity and ecological sites of Amazon. That is one. And the other asks about the use of satellite data in order to monitor the Amazon. So can you comment on those two, please, Professor Poveda?
Yes, I think we are in a good shape, I would say. There are very serious programs for monitoring deforestation, especially satellite imagery, with different or associated with different institutions. For instance, in Brazil, there are several governmental institutions in charge of monitoring on real-time deforestation on a very small scale, spatial scale, and there are also international institutions. University of Maryland, as I said, has this Global Forest Watch program, which is able to measure also deforestations at a very local or very small scale in real time. So I think the future and the situation today, it's okay in terms of the monitoring capabilities. The problem is always the how to put in place the programs, the measures, and the control of deforestation at a very local scale. Due to the, as I said, in many places, lack of real governance from the local governments, and the forces that are driving deforestation, as I said before, have have a lot of power in the Amazon River Basin. So the situation of monitoring, it's okay, I would say. Of course, there's always room for improvement, but there are monitoring capabilities in the Amazon countries, especially in Brazil. I'm not sure about Colombia. Perhaps there are, well, if you look at with a historical perspective, the situation has improved a lot in the last 30 years. But I think that in terms of monitoring, we are in good shape. For me, the real problem is how to uh, having the information and having the results of these monitoring systems, how to curb and how to stop deforestation at a local scale in terms of the lack of governance and the strong forces that are driving deforestation in the Amazon.
Thank you, Professor Poveda. I have another question from Christian Rodriguez. He said, if monetary resources were unlimited and political barriers didn't exist, let's say a perfect world, what would you do first in order to address the conflicts presented in the Amazon? This is utopical, I know, but it's nice to hear from you because you are an expert on that.
I am a scientist, I'm not a politician. But, one of the problems of deforestation is that the economy, our current economic model, fosters deforestation to widen the agricultural or the cattle ranching or the mining frontier, right? So, and the forest is not preserved because the economy doesn't value the ecosystem services provided by the forest. For instance, climate regulation, hydrological integrity, evapotranspiration, cooling, house of biodiversity. So the economy doesn't value all those ecosystem services that the forests provide to mankind and at a global scale. So if I had a lot of money, I would pay for not spreading the agricultural or the cattle ranching or the mining frontier, recognizing the people who live in the region with enough economic resources to preserve the forest in terms of preserving those ecosystem services instead of fostering deforestation. Because as I said, deforestation is caused and fostered by the economic model. So a honest economy would have to recognize and pay for all those ecosystem services that are provided by the forest. And that way, a honest economic model wouldn't foster the deforestation and the degradation of the forest. So I would put those money, that infinite amount of money, as our colleague said, at the service of halting deforestation and preserving the ecosystem services provided by the forest.
Thank you, Professor Poveda. We are running out of time, but I have a question for you. Last year here in Bogota, we experienced a water scarcity problem that lasts for almost 1 year. And you mentioned in your presentation that the moisture traveling from the Atlantic to the Andes is reducing because of deforestation. So in that sense, how to make the decision makers aware that the water from a basin is not coming from the contour of the divide, but the water is coming far away from the forest, for example. What would you suggest?
Yes, that's a very important question, because there is a lot of ignorance in politicians and stakeholders about that very issue. It happened to me many times when I present this video of the water vapor transported by the winds from the ocean to the Amazon and from the Amazon to the Andes. People say to me almost immediately, "I didn't know that. This is impressive. This is mind-changing." So education is one part of this struggle. As that's my involvement in this topic is about education. But also knowledge, of course, of not only the scientific knowledge to the scientists, but to the stakeholders and the policymakers, because everything starts with education. So, for instance, in Bogota, if I were the chief of the water supply system in Bogota, I would be investing money in maintaining the tropical rainforest in the Amazon, because the tropical rainforest in the Amazon provides the water that are going to feed the paramos and the glaciers that provide water supply for many cities in the Andes, including Bogota, including La Paz, including Lima, including Quito, and hundreds of towns and cities in the Andes. And as I said before, also cities like Buenos Aires and Sao Paulo are affected or are provided of water from from the Amazon rainforest evapotranspiration, driven by the aerial jets and the flying rivers. So not only water supply for Bogota. For instance, last year in Bogota there was tremendous water shortages associated with the drought, but also in Ecuador there were tremendous electricity shortages associated with the drought. Also because Amazonian countries depends heavily on hydropower to generate electricity. So climate variability, climate change, droughts and extremes, hydrometeorological extremes also cause impacts in not only in agriculture but also water supply and electricity generation, among other things. So I think it's very important to preserve the low-lying Amazon forest, and of course the forest in the Andes, to keep and to maintain the integrity of this, as I said, coupled system between the low-lying Amazon and the Andes.
Thank you, Professor Poveda, and let me again thank you for your presentation, for illustrating us about all the problems that deforestation and fire have on the local, regional, and global climate. So with that, I will pass over to Petra. So to close the session, and thanks again to everyone for joining us today.
Yeah, I only can also say thank you very much, Professor Poveda, for your interesting and important lecture today. And also to the participants, thank you very much for taking the time, for joining us today, and also for the interesting questions you posed to the lecture of Professor Poveda. And also, Erasmus, thank you very much for doing the moderation today, and my colleagues will put the lecture on our YouTube channel and inform all the participants when the video is online. So if you would like to look up specific topics, you can do so via our YouTube channel. And yeah, unfortunately, this was our last session of the 2025 DAAD Climate Lecture Series, and we are currently discussing whether we will have another series next year. And if we do so, we will inform you via our channels and would be delighted to welcome you again. So thank you very much again for participating today, and have a nice day. Goodbye and see you soon, hopefully.